Mass-energy equivalence, as described by Albert Einstein's famous equation E=mc², states that mass and energy are interchangeable. This principle has several applications in various fields, including wind energy. Wind energy harnesses the kinetic energy of moving air and converts it into electrical energy. Here's a full description of how mass-energy equivalence applies to wind energy, along with some calculated examples. Kinetic energy of the wind. The kinetic energy of the wind is directly related to its mass and velocity. According to classical physics, the kinetic energy of an object is given by the equation Ke equals 0.5 mva², where m is the mass and v is the velocity. However, using mass-energy equivalence, we can express the mass of the moving air as energy. Calculation of air mass as energy. To calculate the mass of the moving air as energy, we divide the energy by the square of the speed of light squared, as given by the equation m=e ca². This conversion allows us to express the mass of the moving air in terms of energy. Wind turbine efficiency. A wind turbine extracts energy from the wind by capturing the kinetic energy of the moving air with its rotor blades. The efficiency of a wind turbine determines how much of the available kinetic energy is converted into electrical energy. The efficiency of a wind turbine is given by the equation I=middle.equals PIN, where pout is the electrical power output and PIN is the power captured from the wind. Calculation of electrical energy. The electrical power output of a wind turbine is calculated by multiplying the captured wind power by the turbine's efficiency, as given by the equation pout equals I=middle.captured wind power. The captured wind power is determined by the mass of the moving air and its velocity. Putting it all together, let's consider an example where the mass of the moving air is 1000 kilograms and the velocity is 10 meters per second. We can calculate the wind's kinetic energy using the equation Ke equals 0.5 mva², which gives us Ke equals 0.5 1000 kilograms, 10 meters per second. A² equals 50,000 J. Next, we convert the kinetic energy to mass using the equation m=e ca², where c is the speed of light, approximately 3×10⁸ meters per second. Plugging in the values, we get m equals 50,000 J. 3×10⁸ meters per second. A² A 5.56×10⁻11 kilograms. Assuming a wind turbine efficiency of 40%, we can calculate the electrical power output using the equation pout equals I=middle.captured wind power. Let's say the captured wind power is 1 megawatt. Thus, pout equals 0.4 times 1 million. W equals 400,000. W equals 400 kilowatts. These calculations demonstrate how mass-energy equivalence can be applied in wind energy. By understanding the relationship between mass, energy, and efficiency, we can quantify the amount of kinetic energy in the wind and determine the electrical power output that can be harnessed from it.